So hi guys, so we'll be continuing on seeing from the previous lecture wherein we saw that remaining oxygen and carbon monoxide reacts together to form carbon dioxide, and similarly carbon dioxide and carbon which was left over from the reaction combines to form carbon monoxide. So we'll be first seeing the summary of what we have actually discussed in the previous lecture. Okay, so if carbon and oxygen are present in mole ratio of 2:1, then only CO is formed. If carbon and oxygen are present in the ratio of 2:1, then only carbon monoxide is formed. Okay, if carbon and oxygen are present in the ratio 1:1, then only carbon dioxide is formed. If carbon and oxygen are present in the ratio of 1:1, then only carbon dioxide is formed. Okay, and the last one, that if carbon and oxygen are present in the mole ratio of 2:1 to 1:1, then both CO and CO2 would be formed. So if carbon and oxygen are present in ratio between 2:1 and 1:1, then both CO2 and CO are formed. Okay, so let's have a question to discuss on. So we have carbon plus half moles of oxygen, it forms carbon monoxide, and carbon plus oxygen reacts to form carbon dioxide. Okay, so first is 16 gram oxygen, so if we take 16 gram oxygen, okay, so what will happen? So let's say we have taken 16 gram oxygen, then we have taken 0.5 moles of oxygen. Okay, and then we would be having 1 mole of carbon monoxide that would be formed. Okay, so let's say moles of carbon atom are given, that we are taking it 2 as 2. Okay, so let's say what happens when we go by this reaction. So if we go by this reaction, what will happen is C plus O2 will give CO2, it is 0.5 and it is 2. After the reaction, what will happen? 1.5 would be remaining. Okay, this would be exhausted and 0.5 would be of CO2 would be made. Now what will happen? CO2 will again react with C to form 2 moles of carbon monoxide. Carbon dioxide is 0.5, carbon is 1.5. Then what will happen is we'll get 1 mole of carbon monoxide produced. Okay, and 1 mole of carbon atom would be left. No further reaction will take place between carbon monoxide and carbon atom. Okay, so we would have 1 mole of carbon monoxide produced. And what happens if we take the first reaction first? So with first reaction, C plus half O2 gives CO. Okay, so we have 2 moles of carbon, 0.5 moles of oxygen. After the reaction take place, 1 mole of carbon would be remaining and 1 mole of carbon monoxide would be formed. So in both the cases, 1 mole of carbon monoxide would be formed. Okay, second example is, or rather second case is, we have 32 grams of oxygen. So what will happen? We have first reaction as C plus half O2 gives CO, and second reaction we have C plus O2 gives CO2. So we have obviously number of moles of carbon atoms we have 2. So if we go by the first reaction, obviously if we have 32 grams of oxygen, number of moles of oxygen would be 1. Okay, so number of carbon moles would be 2, oxygen moles would be 1. After the reaction, what will happen is we'll get 2 moles of carbon monoxide. Okay, and these two would be exhausted. If we go by the reaction 2, what will happen is we have 2 moles here and 1 mole here. What will happen is 1 mole of carbon dioxide would be produced and 1 mole of carbon would be left over. Next, what will happen is this carbon would again react with CO2 to form 2 moles of carbon monoxide, in which we are reacting 1 mole each of carbon and carbon dioxide to form 2 moles of carbon monoxide. So from both, either first step or second, from first reaction or second reaction, we will have 2 moles of carbon monoxide produced. Okay, here we had 1 mole of carbon monoxide produced. Let's see what happens in third case, wherein we have, let's say, 48 grams of oxygen available. So from first reaction we can say that C plus half O2 gives CO, and second we have C plus O2 gives CO2. So what will happen here is we will have 1.5 moles of oxygen and carbon atoms would be 2. We have already given in the reaction. So 2 and we here 1.5. What will happen next is, after the reaction we would have, obviously this is the limiting reagent, carbon is the limiting reagent, so this would be exhausted. 2 moles of carbon monoxide would be produced and 0.5 moles of oxygen would be remaining. Next, what will happen is this oxygen would be reacting with carbon monoxide to form carbon dioxide. Okay, so what would happen next is this will be taking part as, after balancing, will be needing half mole of oxygen here. So how many moles of oxygen are remaining? 0.5. And how many moles of carbon monoxide are there? 2. Okay, so obviously O2 is the limiting agent. Why? 0.5 divided by 2 is 1 and 2 divided by 1 is 2. Okay, so this would be getting exhausted, and as a result 1 mole of carbon monoxide and 1 mole of carbon dioxide would be formed. Okay, so this is according to reaction 1, and I hope the same goes for reaction 2 as well, but let's see and verify. So we have 2 moles here, 1.5 moles here, remaining would be carbon moles. This would be getting exhausted, and will it be getting exhausted? I don't think so. It will be getting, yeah, it will be getting exhausted, but with the 0.5 moles of carbon atom remaining. Okay, and this would be formed as again 1.5 moles. Next, what will happen is this carbon atom would again be reacting with CO2 to form 2 moles of carbon monoxide. So we have 0.5 here, 1.5 here. So after the reaction, this would be getting consumed, and 1 mole of CO2 would be remaining, and again 1 mole of carbon monoxide would be remaining. So in both the cases 1 mole of CO and CO2 would be formed. So I'll just leave 2 more questions to you guys. You need to figure it out. So D part is, what if we have 64 grams of oxygen, and E part is, what if we have 80 grams of oxygen. 80 grams of oxygen. Okay, so I hope here you get that only CO2 is formed as a result. Check with both the approaches, wherein first you take carbon plus oxygen gives carbon monoxide, and second you take carbon plus oxygen gives carbon dioxide. Okay, and here So I'll leave this as an open question here to identify the result. So now let's take another question. Here we have sodium when reacts with oxygen forms Na2O and Na2O2, and also a fact is known that Na2O can be converted to Na2O2 on exposure to air. Okay, so calculate the molar composition of the final mixture if 4.6 kg of sodium reacts with 1972 or rather 1792 beg your pardon liter of oxygen at 1 atm and 273 Kelvin. Okay, so we have been given that Na reacts with O2 to form Na2O. Okay, and also that Na reacts with O2 to form Na2O2. So let's balance these two equations. So here half, 2 and half here, so it is balanced, and here 2 here. And also the fact is known that Na2O can be converted to Na2O2 on exposure to air. Okay, so we'll keep that fact in mind, and we have to calculate the molar composition of the final mixture if 4.6 kg of Na reacts with 19 or rather 1792 liter of O2 at pressure equals to 1 atm and temperature equals to 273 Kelvin. Okay, so what will happen here is, let's say we have so number of moles of sodium would be 4600 gram divided by 46, that's the weight of, or rather 23, that's the molar mass of sodium, so it would be 200 moles. Okay, so let's say x moles of sodium were used in the first reaction, so it would be x by 4 moles of oxygen would be consumed here, and x by 2 moles of Na2 would be produced here, and in this reaction 200 minus x moles of sodium would be used here, and 200 minus x by 2 of moles would be again used here, and produced would be again 200 minus x by 2. Okay, so moles of oxygen we can calculate by PV upon RT. Okay, so this will give us 80 moles. Okay, so we know that total how much moles of oxygen were used. This is x by 4 plus 200 minus x by 2, so which equate this to 80. So from here we can get the value of x as again 80. Okay, so what is the total amount of Na2 which is formed? Na2 formed here would be x by 2, which is 40 moles here, and what is the moles of Na2O2 formed here? Na2O2 would be again 200 minus 80 by 2, which is 60 moles. Okay, so you can easily calculate mole percentage of Na2O and Na2O2 from this calculation. So with this we come to an end of this lecture. In the next lecture we'll be seeing sequential reactions. Okay.